Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook, this one small algebra slip lost more marks than any other on last year's papers, not because the maths was hard, but because students dropped a sign or forgot to handle the coefficient properly. If you want full marks on completing the square questions, you need a reliable route that catches those slips. Stick with me for the next 10 minutes and I'll show you exactly that.
Sound familiar? I remember thinking the method was just a pile of steps until someone explained the why behind them.
The concept. Start simple. We want to rewrite a quadratic like x squared plus 6x plus 5 into a neat vertex form that looks like x plus p squared plus q. That form tells us the turning point of the graph immediately. P is the horizontal shift, q is the vertical shift. Here's the step-by-step using x squared plus 6x plus 5.
Step 1. Focus on the x squared and x terms. Take x squared plus 6x. Ignore the plus 5 for a moment. We will complete the square for those two terms. Why? Because when you have something like x plus 3 squared, it expands to x squared plus 6x plus 9. Notice the extra plus 9. That tells us what to add and subtract.
Step 2. Find the number to make a perfect square. Take the coefficient of x, that's 6, halve it to get 3, then square to get 9. So we add and subtract 9. X squared plus 6x plus 9 minus 9 plus 5. Group the first 3 as a square. X plus 3 squared minus 9 plus 5. Combine the constants, x plus 3 squared minus 4. That's the vertex form.
So the vertex is at x equals minus 3 and y equals minus 4, right? Because x plus 3 squared minus 4 hits its minimum when x equals minus 3. Nice and tidy. Exactly. And here's the why. Halving the b term gives the shift because x plus b over 2 squared expands to x squared plus bx plus b over 2 squared. We deliberately add that square to create the perfect square trinomial and then remove the extra value by subtracting it again. So algebraically, we haven't changed the expression. We have just rewritten it in a more useful form. Important note, this example had leading coefficient a equals 1. When a is not 1, you must factor it out of the x squared and x terms first. We'll do that in the extra practice a little later. Quick check you should say out loud while working. Half the x coefficient, square it, add and subtract. Say it once and it stops you making the common arithmetic slip. The exam technique, what examiners want to see. For a question asking, write in completed square form on higher tier, marking often looks like this. M1 for forming the correct square term, or factoring a from the first two terms. M1 for manipulating the constants correctly, 9. So always show the intermediate square and your combination of constants. So if I make a small sign error at the end, but I've clearly shown x plus 3 squared minus 9 plus 5, I can still get the M marks.
Yes, if the marker can see the correct method, your perfect square and the constants handled, you get the method marks. You might lose the final accuracy mark if the final arithmetic is wrong, but method marks add up. That's why I always say, write it down, don't just think it. Examiners love to award M marks where the method is visible.
Common marking mistakes that lose marks. 1. Forgetting to divide the x coefficient by 2 before squaring. 2. Failing to factor out a when a does not equal 1. 3. Dropping the negative sign when combining constants. You can avoid all three with a short habit I'll give you next.
The quick win, a 10-second sanity check you can use every time. After you complete the square, expand your completed square expression quickly in your head for one line and confirm it matches the original quadratic's first two terms. For example, if you have x plus 3 squared minus 4, expand x plus 3 squared to x squared plus 6x plus 9
and check that the x squared and 6x match the original. If they do, focus only on the constants next. This catches the most frequent sign and coefficient errors in under 10 seconds.
And the memory aid for when A isn't 1.
Simple phrase. Factor A, half the B inside. Concretely, if you have 2x squared plus 8x plus 6, factor 2 from the x squared and x parts to get 2x squared plus 4x plus 6. Now complete the square inside the brackets. That avoids the mistake of halving the wrong number. Or use the formula x-coordinate equals minus b over 2a as a quick cross-check. Both approaches agree, and that agreement is a confidence boost in exams.
Recap and CTA. One-sentence summary. Completing the square rewrites a quadratic into vertex form, so you can read the turning point and collect method marks, and the 10-second expand and check saves most slips. If you want 50 worked solutions covering every topic we discuss on this show, visit jcacademyonline.co.uk for downloadable notes and practice sheets.
Extra practice walkthrough. Let's do a slightly trickier quadratic at speed. 2x squared plus 8x plus 6. Step 1. Factor 2 from the x terms. 2 times x squared plus 4x plus 6. Step 2. Half the 4 to get 2. Square it to get 4. Add and subtract 4 inside the bracket. 2 times x squared plus 4x plus 4 minus 4 plus 6. Step 3. Group. 2 times x plus 2 squared minus 4 plus 6. Step 4. Distribute the 2. 2 times x plus 2 squared minus 8 plus 6. Combine constants. 2 times x plus 2 squared minus 2. So the vertex is minus 2 minus 2.
That's neat. Factoring first keeps everything tidy. If I wrote the intermediate line clearly in an exam, I'd pick up those method marks even if my arithmetic was off at the end.
Exactly. Annotate your work too. Write factor 2 and complete square beside the lines so the examiner can follow your train of thought. Little notes like that turn a messy script into clear method steps, and marks follow clarity.
Final sign-off. Common pitfalls. Don't forget to factor A when A doesn't equal 1, always half before squaring, and always show the perfect square explicitly. Next practice session. Pick 5 quadratics, 2 with A equals 1 and 3 with A doesn't equal 1, and time yourself doing the 10-second check after each one. It'll build speed and accuracy fast. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.